So in the previous video we saw about the vibrations, different type of vibration. That was the natural vibration and the forced vibration. Sorry, damp vibration. Now we are going to see the forced vibration. So forced vibration is the one in which you are giving a periodic force so that it keeps on moving. Like अगर तुम लोग अपने कोई सिबलिंग को अगर झूला झुलाते हो तो वो झूला झुलाते हो क्या करते हैं हम लोग, you just push once, it goes from some time and again you push, give a push and again you give a push so that he is continuously having a good amount of swing. So that particular push what you are giving periodically, and then in such a situation the movement of the swing continuously at a particular amplitude is called as a forced vibration. So that's forced vibration. The vibration of a body which takes place under the influence of an external periodic force acting on it are called the forced vibration. So it is basically the vibrations. You can see that the vibrations are taking place on the influence of external periodic force. It's not the force which is given only once. It is a force which is given continuously at a particular period. Okay, एक बार धक्का मारा, फिर दो बार वो घूमा, उसके बाद फिर से एक धक्का मारा, वो दो बार गया, उसके बाद फिर से धक्का मारा, या तो एवरी टाइम धक्का मारा वापस आया, धक्का मारा वापस आया, धक्का मारा. So in this way, when you are giving a periodic force so that the particular body is continuously in vibrational motion, then we call that particular kind of vibrational motion as the forced vibration. The body executing the forced vibration is thus acted upon by three forces. So अभी क्या था? पहले natural frequency में there was only one force, restoring force, which was continuously making it go steadily. In damp vibration, what was happening? There was a period restoring force, but then there was an opposing force, that was the frictional force or the resistive force, which was stopping the frequency to take place, and hence it is dampening. Now there is a third force over here, which is the periodic external force. So in this case, in a forced vibration, there are three forces which are going to act. One is the restoring force. The second one is the force that is the dampening force, or we can say the resistive force. And the third one is the periodic force which is given to you. So the restoring force, the frictional or the resistive force, and the external periodic force are the three forces which are acting on the forced vibration. When the external periodic force is applied on a vibrating body, the body no longer vibrates with its own natural frequency, but it gradually acquires the frequency of an applied periodic force. So that's it, the external periodic force. So when the external periodic force is continuously given, at that time, what exactly happens is then the body cannot be moving with its own natural frequency. It will be dependent on the periodic forces which are applied on it. So you can, that's why they are given here that when the external periodic force is applied on the vibrating body, the body no longer vibrates with its own natural frequency, but it is gradually acquiring the frequency of the applied force. The external applied force is called as the driving force. Of course, that is the driving the swing also. So it is the driving force, or the driving force is the one which is the cause of the forced vibration. The amplitude of the forced vibration depends on the frequency of the external force. If the frequency of the external force is different from the natural frequency of the body, the amplitude of oscillation is very small, which die out soon due to the presence of dampening force. But if the frequency of the external force is exactly equal to the natural frequency of the vibrating body, the amplitude of the oscillation is very large. In absence of dampening forces, the amplitude of vibration at resonance is infinite. So in case of a forced vibration, there could be two kind of amplitudes which are available. If the frequency of the application of the periodic force is not equal to the natural frequency of the body, okay, natural frequency से थोड़ा अगर अलग है, then the amplitude will be quite small. The amplitude, if the frequency of the periodic force is not equal to the frequency of the natural frequency of the body, then the amplitude will be small and it will die off because of the restoring force or because of the resistive force. But if the frequency of the force applied, the periodic force applied, is exactly equal to the natural frequency, then the body is going to vibrate with the maximum amplitude, which is the amplitude which it gets during natural frequency. The body always vibrates with the maximum amplitude at its natural frequency. That's the reason when you are applying the periodic force in the way that it is going to be hitting exactly at the natural frequency, then you will find that the amplitude with which it is moving is going to be maximum. So as such, theoretically it is seen that in the absence of dampening force, the amplitude of vibration in case of periodic sorry, I missed something. Yeah, the amplitude of oscillation is very large. In absence of dampening force, the amplitude of vibration at resonance is infinite. What is the resonance? We are just going to study in 2 minutes. So let's see about that. Note, the amplitude of force vibration of a body does not remain constant due to the presence of damping forces of the surrounding medium. However, it is possible to keep the amplitude of vibration constant by applying an external periodic force such that the external periodic force compensates for the loss of energy in each vibration due to the damping force. The vibration of the body then are called as sympathetic vibration. So, yes, of course, it is going to be such a way that when you are having a periodic force given to it, that is not going to happen that the vibrations will be having the frequency which will be continuously the same, but there will always be a decrease in the amplitude. There will be dampening due to the dampening force, due to the resist force. There will be dampening of the frequency, but dampening of the amplitude. But you can see that if we are giving the force in such a way that whatever was the energy which was lost in overcoming the friction is given by the periodic force, then we can see that we can maintain a particular amplitude of vibrations by giving a certain particular periodic forces. So that's what they are saying, that if it is possible to keep our amplitude of vibration constant by applying an external periodic force such that the external periodic force compensates for the loss of energy in each vibration due to damping forces. And such a vibration of the body is called as sympathetic vibration. Examples of force vibration: when a stem of a vibrating tuning fork is pressed against the top of a table, the tuning fork forces the force vibration into force vibration in the tabletop. The tabletop has a much larger vibrating area than the tuning fork, so the force vibration of the tabletop sends forth a greater energy and produces a louder or more intense sound than that produced by the tuning fork. So tuning fork say force vibration क्या होगा, tuning fork है वो तो एक particular frequency पे है, I'm hitting the wire and then I'm placing it on the table. So if I press it on the table will also start vibrating, and because of the vibration on the table, because the transfer of vibrations from this part here, the surface of the vibration is bigger. So bigger the surface, more will be the amplitude, and hence the vibrations can be increased. So this gives you a louder sound, or can be produced on a table with that particular tuning fork. Second, the vibration produced in the diaphragm of a microphone sound box with frequency corresponding to the pitch of the speaker are the force vibration. So जो भी speaker में you can always see that there is a vibration of the black color, that part over there, so that vibrations are the same with which the speaker is speaking. So speaker का जो बोलना है and the vibration that are same, so that is nothing but force vibration. In a guitar, when an artist plays on its string or by his fingers, the vibration in them causes the force vibration in the air enclosed in the hollow box. So you can see that guitar में string तो है, उसको तो हम लोग ने या vibration दिया, but that is causing the जो गिटार के अंदर का जो साउंड बॉक्स है, तो the hollow box जो है उसके अंदर जो air है, it is causing the air to be under force vibration due to the vibration of the string. So that is the force vibration in the air enclosed in the hollow box. In string instruments provided with hollow sound box containing air, Strings are made to vibrate by plugging them with produce force vibration in air of the sound box. So that's it. So when you are having any kind of a string instrument, you'll always find that there will be a sound box behind the strings, so that the string, when it is put into vibration, it produces force vibration into the air column which is there inside the sound box, which is behind the string. The surface area of the air in the sound box is large, so the force vibration of the air sends forth a greater energy and causes a loud sound. So यही गिटार का अगर हम लोग ने स्ट्रिंग लिया, वो स्ट्रिंग हम लोग ने गिटार को टच कनेक्ट किए बगैर अगर बाहर रखा, stretch it properly and I put it, do I get the full sound as a guitar? No, you'll not get the sound of a guitar. Why? Because वो जो sound of the string है, वो string को बाद में it is getting amplified, or you can say it is causing a force vibration to the air column which is there inside the sound box of the guitar. So जितना बड़ा गिटार उतना ज़्यादा air column उसके हिसाब से louder the sound. So more the vibrating area, more the surface of vibration, and that's why more will be the sound. So that's why we get that the sound will be produced, will be greater if the sound box which is there is more. So bigger the guitar, bigger will be the sound produced by that particular guitar. So difference between natural frequency and force vibration. So natural or free vibration, the vibration of the body in absence of any resistive or external force are called as natural vibration. Force vibration, the vibration of a body in medium in presence of an external periodic force is called as force vibration. Natural, the frequency of vibration depends on the shape and size of the body. Here the frequency of vibration is equal to the frequency of the applied force. Natural में the frequency of vibration remains constant. Here the frequency of vibration changes with change in the frequency of the applied force. Finally, fourth point, the amplitude of the frequency remains constant with time, whereas the amplitude of frequency depends on the frequency of the applied force. So this is the differentiation between the natural frequency and natural vibration and the forced vibration. We now move on to the next part, which is the most important part of the chapter, that is called as resonance. So we have got force vibration, and force vibration के अंदर का एक condition है which is called as resonance. So resonance is a special kind of force vibration. We just understood that अगर मेरा periodic force is exactly equal to the natural frequency of the object, then, so if my periodic frequency with which I am hitting that particular thing is exactly equal to the natural frequency of the object, then the amplitude of that particular wave will be extremely high. The amplitude of the sound will be very high, and that condition is called as resonance. So resonance is a special kind of force vibration where the external periodic force, okay, matches with the natural frequency of the body. Okay, so hence, because it is matching with the natural frequency of the body, hence it tends to vibrate with a higher amplitude, okay, a maximum amplitude, because the body is going to have the maximum amplitude only when it is moving with the natural frequency. Okay, so when we talk about resonance के बाद के टाइम का जब बात करते हैं, तो simple thing is that periodic force जो उन्होंने दिया वो ऐसा है जो उसके natural frequency के साथ coincide करता है. That is why the amplitude what you are going to get will be exactly the same. Now this is seen maximum when you are playing cricket or football or any particular game wherein you are going to play a shot. So you will find that many a times the player would have just hit the ball so slowly, but the ball goes as a bullet towards a boundary, or the player would have just kicked the ball very slowly without much of an effort. You don't feel that he had put on too much of efforts, but still the ball is going in a very nice shot. Why is it so? because when you are hitting the ball with the natural frequency of the particular ball, then the amplitude with which it is going to travel is going to be the maximum, and that's the point. And इसको स्पोर्ट्स के लैंग्वेज में बोलते हैं टाइमिंग ऑफ द शॉट. Okay, you can always say क्या शॉट का टाइमिंग है. What does it mean by timing? The timing means that it is being played in such a way that the frequency of the ball and the frequency at which it is being hit, the फोर्स वाइब्रेशन का जो पीरियोडिक फोर्स जो है वो, और वाइब्रेशन ऑफ बॉल जो है उसका जो पीरियोडिक वाइब्रेशन है वो इतना पर्टिकुलर है कि वो एग्जैक्टली इक्वल होने के कारण इट इज गोइंग टू ट्रैवल with the best kind of speed. So this is something which is going to be helpful, but of course you don't know exactly कि क्या frequency और किससे समाना, but that's why practice comes into picture. Then that is why the players are able to kick the balls or they are able to hit the shots in such a way that हम लोग को अगर कितना easily मारा, वही कि हम लोग मारने जाते हैं तो हाथ में झटका लगता है, सब कुछ तकलीफ होता है, no? That is why that's the difference between the practice and a layman. So when a body vibrates in a medium under the influence of an external periodic force of frequency exactly equal to the natural frequency of the vibration of the body, it is said to execute the resonant vibration. So yes, that's what they are saying, that if the body is at a periodic vibration, influence of periodic vibration, उसके अंदर अगर वो periodic force जो है it is exactly equal to the natural frequency of the vibrating body, then the body will execute resonant vibration. These vibrations are of large amplitude. The amplitude of resonance depends on the frictional forces. Thus, resonance is a special case of force vibration. When the frequency of the external applied periodic force on the body is equal to its natural frequency, the body readily begins to vibrate with an increased amplitude. So what does it say is that in resonance, it is a special kind of force vibration when the frequency of the externally applied periodic force, the frequency of the externally applied periodic force is exactly frequency of the externally applied periodic force of body is equal to the natural frequency of the body readily starts to vibrate. Okay, the body begins to vibrate with the increased amplitude. This phenomena is called as resonance. The vibration of large amplitude are called the resonant vibrations. Suppose the body is set to vibrate freely and it vibrates with the frequency f. It is natural frequency of vibration of body. Now let a periodic force of f of frequency n be applied on the vibrating body. If n is equal to f, the resonance takes place and the body starts getting energy from the source of the applied periodic force, so its amplitude of vibration is increased. In case n is greater or less than f, not equal to f, there is no resonance and the body will execute only force vibration or small amplitude. So that's the thing. It is such a thing that it has to be absolutely precise. If frequency exactly equal to the natural frequency, beautiful amplitude, exactly, excellent large amplitude. If it is slightly less, low amplitude. If it is slightly more, still low amplitude. So amplitude will be low even if the periodic force is higher or lower than the natural frequency. अगर वो exactly equal to natural frequency है तो must वो amplitude higher amplitude से वो travel करेगा. So that is about the resonance. So that's why we have the conditions for resonance. So what are the conditions for resonance? First thing is resonance occur only when the applied force causes force vibration in a body and the frequency of the applied force is exactly equal to the natural frequency of the vibrating body. So first condition is that it is going to happen only under force vibration. So resonance के लिए first condition is that there should be force vibration, and what is the second condition is that the force vibration should be such that the application of the periodic force will be exactly equal to the frequency of the natural frequency of the body. So that is the condition for resonance that it will be under force vibration, and the frequency of the applied force is exactly equal to the natural frequency of the vibrating body. At resonance, a loud sound is heard, but because the body vibrates with a very large amplitude, sends forth a large amount of energy in the medium. So you've always seen that whenever the resonance is there, whenever the body is under resonance, it will always be moving with a very large amplitude. So that will always produce a larger sound. So that's why a large sound will be heard when resonance is coming into picture. Because the amplitude is higher, so energy produced or energy which will be going forth will be put forth will be higher, sent forth will be higher. Demonstration of a resonance. The phenomenon of resonance can be demonstrated by the following experiment. Experiment 1. Resonance with tuning fork. Mount two identical tuning fork A and B on the same frequency on two separate sound box such that their open end face each other as shown in the figure. So sound box is only a box with one side and open, otherwise पूरा box है पर ये side open है और उसके ऊपर एक छोटा सा एक होल है जहाँ पे हम लोग एक tuning fork रख सकें. So one sound box like this, another sound box like this, and then the tuning fork can be placed over here like this. Okay, so one over here and one over here. So I can have this both tuning fork placed up over here like this on the sound box. What I'm going to do is that this particular tuning fork, I'm going to hit it and start into vibration and place it over here. So this is under vibration. Do the vibration in this, there is a vibration in over here. ये vibration इसमें जाएगा तो ये भी vibrate होने लगेगा, and you will find that accordingly this tuning fork will also set into vibration. This is because this vibration of this tuning fork is at a particular frequency. यही frequency से यहाँ पे sound generated हुआ, वही sound generate जो frequency से वही sound generate यहाँ पे भी हुआ, and since the tuning fork of the same frequency is over here, so that particular frequency of this is also the natural frequency of this particular tuning fork, and hence this tuning fork will also start vibrating with the same frequency because of force vibration but resonance. So you can see that when a prong of one of the tuning forks, say A, is struck on the rubber pad, it starts vibrating. On putting the tuning fork A on its sound box, we find that other tuning fork B also starts vibrating and a loud sound is heard. Reason? The vibrating tuning fork A produces the force vibration in the air column of its sound box. These vibrations are of the large amplitude because of the large surface area of air in the sound box. They are communicated to the sound box of fork B. The air column of B starts vibrating with the frequency of A. Since the frequency of these vibrations is same as the natural frequency of fork B, the fork B picks up this vibration and starts vibrating under resonance. Thus the two sound boxes help in communicating the vibrations and in increasing the amplitude of vibration. So this is how the sound which is produced by both these tuning forks is going to be of increased amplitude due to both of them helping each other in vibration. Second one, force and resonant vibration of pendulum. Take four pendulums A, B, C and D, suspend them from the same elastic support. So you have got elastic support. So this is the elastic support, so it can give you a good amount of movement itself. We are going to have four tuning forks A, B, C and D, wherein A and B are of the same length, whereas D is bigger and C is smaller. So take four pendulums A, B, C and D, suspend them from a same elastic support, say from the piece of stretched rubber string PQ as shown in the figure. A and B are pendulums of the same length, so their natural frequency of vibration is same. D is of pendulum which is of longer than A or B, so its natural frequency is lower than A or B. Their pendulum C is shorter than A or B, so its natural frequency is higher than of A or B. The two unequal ones C and D are being suspended on either side of pendulum B. The pendulum A is set in vibration by placing the bob on one side, normal to the length of Ra. So what you are doing is you are taking this thing and taking it on this side and setting into vibration. So ये vibration पे आएगा. So you will find that this will set this into vibration in the same amplitude as this. So this too will be at the same amplitude, where this will be at lesser amplitude. So why is this so? Because this one is going to set the vibration into the rubber string, the same frequency with which it is vibrating, and that is also the same frequency of this particular pendulum. So this picks up the natural frequency of vibration, and that's why this will be under resonance. Hence the amplitude of this will be the same as A, that is the natural frequency. Whereas यहाँ पे दोनों के लिए it is just the force vibration, so the amplitude will be less. So the observation will be that the pendulum B starts vibrating initially with a small amplitude, and ultimately it acquires the amplitude same as the pendulum A initially had. When the amplitude of B becomes maximum, the amplitude of A becomes minimum because of the sharing of energy by them. Thereafter, the amplitude of B decreases and that of A increases. This process continues. The vibration of pendulum B are in phase with those of A, that is, they reach their extreme positions on either side simultaneously. The pendulum C and D also vibrate, but each of them vibrate with a very small amplitude. So here we can see that A and B will be in phase. ये अगर maximum पे जाएगा तो ये भी maximum पे जाएगा. और पर कैसा होगा कि this will be sharing the energy, so both will not be having the same amplitude at the same time. When this will be maximum, this will be minimum. When this is minimum, this is maximum, this is minimum. So the vibration produced in pendulum A are communicated to the force vibration to the other pendulum B, C and D through the rubber string PQ. The pendulum C and D remain in the state of force vibration, while the pendulum B comes in the state of resonance, because of the natural frequency of pendulum B is equal to that of A, being of the same length, and therefore there is an exchange of energy between pendulum A and B. So that's what they are saying, that when this is going to set this into vibration, so the vibration of this is going to be equal to the vibration of this because of the natural frequency, and hence the energy from here is transferred to the energy over here. When the amplitude of pendulum B increases, the amplitude of A decreases and vice versa. So पहले क्या होगा, इसका amplitude बढ़ेगा तो इसका decrease होगा, because the energy is transferred from here to here. Now when its energy is increased, तो उसका energy इधर आके इसको आएगा. So this will produce energy and this is going to use the energy, and so this becomes maximum, this becomes minimum. So amplitude of A and B will be alternating. Okay, पहले A का ज़्यादा है तो B का कम होगा, B का ज़्यादा अपने आप होगा तो A का कम हो जाएगा, फिर B का ज़्यादा है तो धीरे धीरे A का बढ़ेगा और B का कम हो जाएगा. So accordingly A and B will be in phase with each other, that one will be having maximum amplitude, the other will be having minimum amplitude. And when other has got a maximum, this will be minimum. So when the amplitude of pendulum B increases, the amplitude of pendulum A decreases, and vice versa. The pendulum B therefore vibrates with the frequency of the pendulum A, and it remains in the phase with the pendulum A. So that is how it is going to be seen, that the pendulum are going to be in phase with each other. So that was the second experiment regarding resonance. Now we move on to the third experiment of resonance, but just check it out. Yeah, I'll take it in the next video.